I'm delighted to have the chance to talk to Bernard Carr. Hi there, Bernard.
Hi, Mark.
We've talked sort of intermittently over a few years now. Normally when I've shown up in your office and asked you some big question and whether you can help me with some clarification. But one thing you told me once, which I've always loved, was an anecdote about your time with Stephen Hawking, the very famous physicist who you work with on black holes. And this was the time you went to see the premiere of the film about his life, The Theory of Everything. And I wondered if you could just begin by telling us that story, because it's such a good one.
All right. Well, I should first explain that I was Stephen's PhD student, in fact, one of his first PhD students. And I went with him to Caltech, and I lived with the family at that time for a whole year. So Stephen and the family became good friends. And when the film, The Theory of Everything, was made, of course, it was talking about Stephen of the history of Stephen's ideas and his love affair with his wife. When the film came out, I was very kindly invited to the premiere in Leicester Square, and actually it was the first premiere I've ever been to for a film. And so Stephen was there and with Jane and various friends, and I was more or less sitting next to Stephen. So I was particularly interested to see how Stephen would react to the film, because the film, of course, was very much based on Jane's book. And you remember Stephen and Jane had split many years before, so it wasn't completely obvious that Stephen would be comfortable with this. But anyway, I sat next to Stephen. Now, the title of the movie was Theory of Everything. And this was appropriate because in some sense Stephen's whole life was geared towards finding the theory of everything. And indeed, that is the aim of physics as a whole, in some sense, to get the final theory of everything, of all the interactions between physical objects and your unified mathematical description. Now, Stephen never quite succeeded in doing that. No one has yet succeeded in getting a final theory, but maybe we're close to it with M theory and things like that. And well, the story is as follows: that Stephen actually enjoyed the movie, and I know that because I was sitting next to him. And I probably told you a little joke that because Stephen had been seeking the theory of everything all his life, I imagine the newspaper headlines the next day, which would say, Stephen Hawking finds theory of everything, and then, little pause, enjoyable. Well, of course, that wasn't really the newspaper headline the next day, but I thought it would have been a nice headline. But what also struck me about the movie, I mean, I should say, enjoyed it, and indeed I think I featured in the movie as part of one character. They'd merged a few of Stephen's students into one. But what to me was rather ironic about the movie was that, in theory, it was supposed to be, because of the title, you would assume it was about Stephen's work in physics, about his attempt to find a theory of everything, and indeed it talked about that to some extent. But actually what the movie was about was really about his love affair with Jane, who was his first wife. And I found that rather strange, because the one thing a theory of everything in the particle physics sense is not going to explain is human relationships and love. And so from that perspective, I found that the title was rather ironic. And also that resonated with me, because although I'm a physicist, I'm someone who takes the view that despite its triumph in coming to understand everything in the universe, from the very large, from the very small, physics makes no reference to consciousness and to mind. It represents, if you like, the triumph of mindlessness. And to me, that's very unsatisfactory, because half my experience is not in the physical world, it's in my mind, it's in my memories, my dreams, my altered states of consciousness or whatever. And so to me, that represents the fact that physics is incomplete. And in some sense, it needs to expand, perhaps, to accommodate these sort of phenomena. Now, this wasn't Stephen's view, but nevertheless, it was my view, because Stephen was very much a materialist. You know, he thought the physical world was all we needed, and there was no room for anything going beyond that. He wasn't really keen on philosophical and theological type issues. And so, to me, when physicists talk about a theory of everything, they're really only talking about a theory of physics, particle physics, and it's very pretentious because it's nothing like a theory of everything, because it's not explaining half the world, i.e. it's not explaining one's the non-material domains, if you like. And so that's quite a rather long elaboration on the story, but it's why the story is of interest to me, that the title of the film, to me, expresses the puzzle that the theory of everything in physics really isn't a theory of everything, and one needs to go beyond that.
Well, look, it also opens up a number of areas which I hope we can sweep by in the next 3/4 of an hour or so, perhaps, which are related to the business of how mind and matter, consciousness, materiality, and these things might go together. And I know that you're working on that. But the pressing question which actually led me to be in touch with you this time was to do with, well, it was prompted by these new, totally wonderful, amazing images which are now coming to us from the James Webb Space Telescope, you know, reaching back not just across the solar system, not just even across our galaxy, but right back to relatively early stages, so far as we understand it, in the life of the universe. And I think they've reached back to maybe 100 million years or so after the Big Bang, which is really quite something.
Yes, but of course, that's with galaxies. But of course, when you're looking at what's called the background radiation, you're looking back to about 100,000 years after the Big Bang, which is even earlier. But that's before galaxies are formed. But
right, okay, yeah. So
after looking at galaxies, and that's only going back to to a much later time.
Yeah, no, okay, yeah, no, good point. Well, what it led me to wonder about was, what are we actually doing when we look back so far? And I'm influenced in my questioning here by Owen Barfield, the great friend of C.S. Lewis and J.R. Tolkien, who I'm deeply influenced by. And he was often questioning what's sometimes called the principle of uniformitarianism in physics, and indeed across science, which is the idea that the laws of physics have been the same across space and time. And that's an assumption that you make to then, for example, make estimates about how far back across space and time you're looking. And he questioned that because he was aware that certainly since Kant, the philosopher Immanuel Kant, it's been a fairly standard assumption that how we experience and therefore theorize notions like space and time depends upon our consciousness, depends upon our mentality. And that therefore, before there's a mentality to, as it were, at least in part, interpret or even co-create, to use Wordsworth's expression, the sense of space and time, and therefore the measurement of space and time, I guess, too. It's more of an open question, quite what was going on, if I can put it like that. We are participants in the universe. And now in my mind, I also then link that to a comment made by John Wheeler, very famous physicist, when he says, we are in this sense participators in bringing about something of the universe in the distant past. So my naive question, maybe I can ask it naively and then you can pick up what makes sense and tease issues apart, is, are we really just looking back across a kind of linear path of space and time? Or are things shifting? Are we somehow even forging what we're looking at when we look back across these vast expanses of the known universe? Can you pick that up in some way and help, first of all, tease out the sense, and then maybe whether there's any real issues here?
Well, Mark, you have patched together there um, various, maybe 4 distinct issues, which are all very interesting in their own right. But I think I'm going to need to unpack this a little bit to separate those issues. And probably by the end of the conversation, I've forgotten what some of the issues are, but you can remind me.
Okay.
And so, well, let me first of all start off. You talked about the James Webb pictures. And first of all, let me just answer from a strictly astronomical perspective without bringing in any of the sort of philosophical issues which you're referring to. In terms of, in order to understand what's happening when we look back, our model of cosmology is based on relativity theory. In fact, it's based on general relativity theory, and which of course goes back about 100 years. And so it's because of general relativity theory that we're able to understand the universe and understand how we make observations in the universe. And one of the key points about relativity theory is that when you look at an object, light travels at a finite speed. So when you look at something at a great distance, you're also looking back into the past. And so one of the big issues, so if you're looking at something a million light years away, you're looking at something a million years in the past. Now, the Big Bang itself begun 14 billion years ago. So if you're looking really very, very large distances, approaching something like 14 billion years, you're looking back at very, very early times. Now cosmologists understand the history of the universe, fairly well. And let me just say that the first thing you will see, the earliest thing you can see is probably the microwave background sky, which is this background radiation with a temperature of about 3 degrees, which I'm sure you've seen pictures of from the Planck telescope and things, where you see all the color and representing the temperature fluctuations. And that's very beautiful. And it's giving you information about the universe when it was about 100,000 years old. But this is well before galaxies form, but you can still look back to that time. Now, the first galaxies form, well, we don't know exactly when the first galaxies formed, but they probably formed about 1 million years after the Big Bang, so well after the time of the background radiation. But the point is, in cosmology, you're always, when you're looking with your telescopes, you're always looking along the past light cone. That's because light travels at 45 degrees in a space-time diagram. And so when you observe in cosmology, you're looking along a special part of space-time. But as you look back in the past, you're looking at just on this light cone, which is like a surface. So you're seeing objects at a particular time. I hope that's not getting too technical. So the point is, from an astronomical point of view, we look at these objects. The further we're looking, the further back we're looking in time when the universe was younger. And the point is, the more powerful the telescope, the further back you can look because you're looking at smaller objects. So what's remarkable about these pictures, first of all, of course, you have amazing resolution. So you can see these pictures of astronomical objects, be they in the galaxy or further away, which are incredibly beautiful and incredibly precise. But the key point is that you can also, well, one key point is you can also look back to very, very early time. So you're seeing galaxies at a much earlier stage than we've ever been able to see them before, even much earlier than the Hubble Space Telescopes could observe them. And in some sense, there is no mystery about that. Okay, so, and the pictures are incredibly beautiful, and I might say they're also incredibly moving. It fills you with, for me at least, you look at those pictures and it fills you with awe. And, sometimes you think that astronomy and science is just a purely objective, dispassionate study of the outside world, and you're collecting data and trying to work out what happens and how it fits into Einstein's equations. But you look at those pictures, and to me at least, I mean, you are filled with awe and or simply of the beauty of the universe and the amazing the data is not just information. Okay, it's in some sense beautiful, and to me that is a message of science itself. The message you get from science is not just knowledge of the universe. You perceive the beauty in the universe of the universe, and that's, I know that's not the main point you wanted me to make, but I just wanted to stress that. Now, so that's when you're just talking as a physicist about what is the relationship between the object you're seeing through your telescopes and yourself, and we understand that. But then you're raising various other questions. Then you're raising, well, the question of what is the relationship between the outside world, the physical reality, if you like, and our experience of the world. And this is something which applies just when you look around your room. You know, it's not, you don't have to think about looking at stars or galaxies. I mean, this is the same issue in any form of perception. And then, of course, this is an old philosophical problem. What is the relationship between the physical object and the object you experience? And of course, in naive realism, you say that the object is you are perceiving the object directly. But we now know that that isn't true. You now have what's called representative theory, which says you have an outside object that in some sense sends information via light signals or whatever that goes through your eye and into your brain, and this produces inside your head a sort of map of the outside world. So if we look at a distant star, for example, you've got the star in the outside world, and then you've got some little image of a star in your head. And the assumption would be that those are different, that the star in your head is different from the star in the outside world. So, and the difference is that you and I, we're both looking at the same star, so we've got these different little stars in our heads, but there's only one star outside in the physical world. So that's the naive, but the point is, with that view, you realize that your perception of the world is actually is the phenomenal world, if you like, is not exactly the same as the outside world. There are all sorts of ways in which the brain, if you like, or even higher cognitive processes, are changing the appearance of the world and indeed distorting it. So our memories can be distorted and our perceptions of the world can be distorted in ways which are well understood. I mean, we know the sensory system can produce, optical illusions, for example, but more importantly, there are subtle higher order cognitive effects that can change the way the world seems. And so that's the second point I want to make, is that there is obviously a relationship between the outside physical reality and your perception of reality, your phenomenal world, but it's not straightforward. It can be quite complicated. But none of that is really relevant when we're looking through the James Webb telescope, okay? Because then we're just looking at data in an objective way. So that's that's the second point to make. Now, then we get into the question of that you were referring to Barfield, and now that raises a deeper issue altogether, and that's saying, to what extent does our observations actually change the perceived reality itself? Okay, so what I was just talking about was the way in which our perceptual processes change reality, but now we're talking about the third question: can my perception actually change reality itself? Can my mind, my consciousness in some sense, have an effect on the outside world? Now that's a much deeper question, and in a sense a more interesting question. Now, what are the reasons for saying that? Well, one of the points about this is that, for example, within cosmology, there are what's called the so-called anthropic principle. And the anthropic principle says that there are certain conditions, there are certain relationships between the constants of physics which are required in order that there can be observers. And I won't go through all of these relationships. They're relationships between the fundamental constants which describe the interactions of the masses of elementary particles and various cosmological parameters. But I don't want to go into the actual details. It's just saying that there are relationships between physical constants which are required for our existence. And those relationships are unexplained by current physics. Now, there have been various explanations for that. One explanation is a theosophical explanation that maybe the universe was tailor-made for us, if you like. God, if you like, chose the constants of nature so that we could be here. Obviously, that doesn't really appeal to physicists. But there's another explanation, and this came from John Wheeler. And he said, well, maybe we know the universe starts with a Big Bang, but in quantum theory, a physical object doesn't have a well-defined state until it's observed. Okay, and so, for example, I toss a coin and you don't know whether it's heads or tails. Until you look, it's in a sort of fuzzy mixture of heads and tails. Okay, but once you look, it collapses the wave function. And so one thing Wheeler said, well, maybe in some sense the universe is like that. Maybe the universe itself only exists in a sort of funny state, a fuzzy state, until observers have arisen. And now, of course, what happens in the Big Bang is that the Big Bang is expanding and it evolves, and eventually you get stars and galaxies and people and branes forming, and then the consciousness can, in some sense, look back and think about the Big Bang. And so he has a nice little picture, which is like a U picture, where you have the Big Bang at the top, and then it forms a U, and up on the other side you have an eye, which is looking back on the Big Bang, and it forms a sort of closed circuit. So he says, well, maybe in fact consciousness is what brings the universe into reality, that it sort of completes the circuit. It collapses the wave function, and that then brings the universe into existence. Now, I have to say that is not the mainstream view because of physicists. Most physicists find that far too metaphysical, and it does assume that consciousness is collapsing the wave function, and that's not something which all quantum physicists believe, but some take that seriously. But nevertheless, this is an example of how the presence of consciousness or of an observer could actually determine the structure of the universe, because the idea would be that all those universes that didn't have the right values of the constants wouldn't generate consciousness, and therefore the universe wouldn't be collapsed into a specific state. And so this was one particular explanation of the anthropic fine-tunings, which is saying that actually our consciousness is in some very literal sense bringing the universe into existence. Now, nowadays there's a third explanation for these anthropic tunings, which says that there could be what's called a multiverse, that there could be many universes in which the constants are all different, and then we necessarily have to be in one of the small subset of the universes which is going to have the right constants for us to arise as observers. And that's just a straightforward selection effect. And so that's the interpretation of these anthropic tunings which most physicists prefer, because in some sense this prediction of a multiverse comes out of physics. Okay, it's not coming out of philosophy or anything. It's predicted by our theories of cosmology and our theories of particle physics. There are very many scenarios which predict a multiverse. I have to say, not all physicists like the multiverse, because it raises, you can't see the other universes. So some people say this is philosophy rather than physics, but that's another issue. But the point is, there are a lot of famous physicists, people like Steven Weinberg and Stephen Hawking and Martin Rees, who are in fact really atheists, but they don't want to invoke God, to fine-tune the universe, but nevertheless, for them, this is the justification for taking the anthropic principle seriously. Well, so then you might say you've got a choice between this Wheeler picture where consciousness collapses the wave function and this having many different universes. So in some sense, those are different perspectives. But the point is, at least you have you have a hint that consciousness can play a role in the actual form of the universe you observe.
So if I sweep by again, and again, forgive the naivety, but under the Wheeler interpretation, then, could you say something like this, that the physicists can have confidence that they're looking back even to 100,000 years since the Big Bang with the microwave radiation, that makes sense to talk about time in that way, because consciousness was still at least latent or implicit in the cosmos at that stage, if not emerged in the form that we know it, because of the link between consciousness and these cosmological constants.
Well, when I talked about the this closed loop, that is a closed loop in time, if you like, because it's the closed loop which includes the Big Bang and our present time of observation. So that whole picture is still being described in terms of space and time. And so when I talked about observing the Big Bang, and closing the loop, forming a sort of closed loop. I mean, really, even thinking about the Big Bang would have had the same effect in some sense, but it did depend on the actual observation. That in this picture, it's the process of observation which is producing, in some sense, the reality. Now, it's true that you're only observing back to a certain time in the past. And so you might say, well, am I creating the universe before that? If I'm looking back to the microwave background, which is, say, 100,000 years after the Big Bang, you might say, well, okay, what about the state of the universe before that? Because we're not observing that. So you might say, well, is the state of the universe before that still fuzzy? And of course, most physicists would say no. Most physicists would say we can predict how the universe would have behaved at earlier times. But even if we can't directly see it, I mean, actually, maybe we can see it, because maybe we can see it in gravitational waves, or maybe we can see it in neutrinos or some other sort of particles other than photons. So there's a philosophical issue, but what is undoubtedly correct is that in this picture you are looking back in time, and that's a crucial part of the argument. You're looking back in time, and apparently, therefore, you might say naively that this is affecting the past. You might say that if the universe is born in the Big Bang and it expands, and then we observe it back to a certain time, and you might say that is a creation of the past in some sense, because you're saying that the universe, if you're saying the universe doesn't really exist until you observe it, in what sense before that time can I draw a little space-time diagram, for example? And the way you answer that in quantum theory, or even in quantum cosmology, you have to say there's like a superposition of different states of the universe, because quantum theory can be applied to the universe itself. So you can imagine you have a superposition of different states of the universe. So another way, in some sense, of interpreting Wheeler's picture is to say that there are a superposition of lots of possible universes which all exist, but the process of observation is selecting one of those many universes, okay? But in either case, you're having a description which is still in terms of space and time. But you see, your question has raised another issue, which is interesting, which is not quite the same issue, but it's to do with the question of whether the present can affect the past. And this is the famous delayed choice experiment that Wheeler talked about, which is a little bit complicated. But can I have 5 minutes or so?
No, please, because it's great sweeping by this in different ways and teasing things out. So yeah.
Well, first of all, I have to preface this by talking about the famous two-slit experiment. The point about the two-slit experiment is you have a source of light, and then it goes through a screen. It goes through a barrier which has got two slits. Okay, so the photons can go into the left slit or the right slit, and then the photons end on a screen behind the slits, and then you can observe the photons as they land on this screen. Now, I think many of your listeners will know about this, but the paradox is this. If you've just got one hole, one slit, and the other slit is blocked off, then the photons just behave like particles. They go through the particle and they land in a certain way on the screen. And it might go through the left or it might go through the right, depending which slit you open. If you open both slits, then the photons seem to go through both slits, and it behaves like a wave. And because it behaves like a wave, this forms a characteristic interference pattern on the screen. So you get alternate bands of light and dark. And that is simply a prediction of the fact that the light is behaving like a wave. It can go through both slits. But if you block off one of the slits, you get a completely different pattern, and it behaves like a particle. And so this is the whole underlying paradox, if you like, within quantum theory, that a photon can behave like a particle or a wave, but it can't do both, okay? And basically, you as the observer can decide whether it's going to behave like a particle or wave, because if you decide to close one of the slits, it's going to behave like a particle, and if you don't close one of the slits, it behaves like a wave. And that is the most profound mystery of all the mysteries of quantum theory, although quantum theory has many, many other enigmas. Now, that's the standard two-slit experiment. Wheeler suggested another experiment, which again it relates to astronomy and is a little bit more technical. You can imagine you've got a source of light, which might be a star or something. Now, then you imagine between you and the observer, between you as the observer and the star, there is a galaxy. Then, because of the gravitational field of the galaxy, the light gets bent from this star around the galaxy. So if you look at the star, the light may have either gone to the left or the right. And so you actually see two images of the star because of this so-called gravitational lensing effect. But then you ask the question, how does the photon know whether to go to the left or the right of the galaxy? Okay, and this is precisely analogous to the two-slit experiment. How does it decide to go through the left slit or the right slit? And so the point is, therefore, if you're on Earth and you can have a screen and you can look for interference patterns. And what happens is that if your telescope looks at the source, it looks if it came from because you've got two images, you see, and if it's, in fact, it would normally be a quasar rather than a star. You would never see a star. But basically, if you point your telescope to the left, you know it's come from the left. And if you point it to the right, you know it's come from the right. But now you do an experiment in which you don't do that. You just let them interfere. And what you find is you get the characteristic interference pattern. Okay. Now, but you remember the question is, are you closing one of the slits or not? Okay, you've got to make the decision whether or not that you're going to get information about which slit it came from. If you get the information of what slit it comes from, you won't see the interference pattern. Okay, well, in this experiment, you're deciding whether to look to the left or the right image. And if you don't make that decision, you see the interference pattern. And so you can decide long after the photon left the quasar, because it left billions of years ago, whether to do this. But now the great paradox is, how does nature know? How does this light ray know whether you're going to decide to look at whether it came from the left or the right image? I mean, this is exactly the same issue which arises with the normal two-slit experiment.
Mm-hmm.
You can decide whether to look at one slit or the other slit and get rid of the wave pattern. And you can make that decision after the photon has actually gone through the slits.
Right, yeah.
Okay, and that's the paradox. Now, really, Wheeler's experiment is just doing the same thing, but it's only doing it at a source which is billions of light years away. And so the question is, I'm making my decision now. So how did the photon know billions of years before I make that decision whether it was a particle or a wave?
Mm-hmm.
And it's intriguing. It's essentially the same issue, but it's just made dramatically because this was 9 billion years ago. Now this is billions of years ago, and there's two approaches. One approach is to say that, well, actually, maybe you've actually affected the past. Maybe in some sense, you are affecting the state of the universe, or the state of this quasar. You're affecting the decision of the photon, but you're affecting it retrocausally. But the more traditional, the more mainstream interpretation would simply be the universe, the photon is in a state of ambiguity. It can be, it's a wave. It is both and not one of them. So you can see that this is, it's sort of related to the issue I talked about before, about whether consciousness collapses the wave function of the universe. But this is a much more precise problem, because that's talking about the wave function of the whole universe, which is obviously on the border of philosophy. Now we're talking about something which is really mainstream physics. We're talking about the wave function of the photon coming from a quasar. So it's conceptually related, but it's a much more specific issue, which can be actually experimented on. Okay, because this is what the two-slit experiment is. So you can speculate about consciousness collapsing the wave function of the universe, but you can't do experiments on that. Okay, but you can do experiments on the wave function collapsing the wave function of the photon. And so it's a fascinating experiment, and again, we don't know for sure. One explanation could be that the consciousness is altering the past, and I don't know whether that's more consistent with Barfield's view or not. But the other view is that that you just have a superposition of different states until you make an observation. Either of these interpretations are mind-blowing. Either of them can go completely against common sense.
Yeah, I think the Barfield line would be that consciousness is part of the emergence of the cosmos. And so the way that we experience things now is directly related to our consciousness now. And so in principle, in the past, it would have been different. And of course, in principle, in the future, things might look very, very different again, given that consciousness itself isn't static, but evolves, emerges, whatever your word of choice is, over time as well. So some future astronomer might see things very differently again in the Barfieldian take.
Well, I mean, now, Mark, of course, you brought in the whole issue of consciousness and what is the relationship between the cosmos and consciousness. And I mean, we're talking about perception and the relationship between the physical world and the perceptual, the phenomenal world, but you're now asking about consciousness itself, and that's an even deeper question. And so should I just say something about the importance of consciousness? I mean, the point about the universe, it starts with a Big Bang, and I talked about these fine tunings, but the fine tunings, what they're actually allowing is for the development of complexity. As you go through the history of the Big Bang, which we now understand very well, although we don't understand the values of all the constants, we know there are various special periods in the history of the universe where you actually introduce different forms of structure. So, for example, you start off just with this energy, the vacuum energy. At some point, this creates particles, quarks and things. At another stage, these quarks organize themselves into protons and neutrons. Later, the protons and neutrons organize themselves into more complicated, heavier elements. And then later on, you've got fluctuations which are generating, turn into galaxies. You know, those are the fluctuations on the microwave sky, and later the galaxies fragment into stars. The stars have planets. The planets then produce life, or, you know, self-replicating cells, which then evolve into human beings and brains. So you've got this picture. It's what I call the pyramid of complexity. You've got this picture of evolving complexity throughout the history of the Big Bang. And it's like a pyramid because in some sense it's a smaller and smaller fraction of the universe which is involved in these complex systems. So by the time you get, you know, most of the universe, some large fraction of the universe may go into galaxies, but the fraction of the universe that ends up with really complicated things like human beings is a tiny fraction. Okay, so this is why it's a pyramid. Okay, so you imagine this pyramid, the base is the Big Bang. The pyramid represents the evolution in time, and it represents this evolution of complexity. And you can see consciousness, if you like, as being the culmination of complexity. Okay, that's right at the peak. That's the way I look at it, at least. But what you've got to realize is that this pyramid of complexity has only arisen because of those fine tunings of the constants. Because if you didn't have those fine tunings, you wouldn't end up with this pyramid, and you wouldn't end up with the consciousness. That was the anthropic argument. So in that sense, of course, consciousness is obviously important, because if there wasn't consciousness, you wouldn't be making any observations. So it's obvious that consciousness underlies our experience of the universe. Nevertheless, despite that, most scientists probably take the view that consciousness is really just it's like it's an excretum of the brain. You know, they will take the view that that consciousness is just generated by the brain, and that plays a more or less passive role in the universe. Okay, so the laws of physics will carry on. You know, energy is conserved and particles follow the Newtonian trajectories or whatever, regardless of whether anyone is watching them. So that's the mainstream view, that consciousness plays a purely passive role in the universe and is just the excretum of the brain. And so if there was nobody here, the world would carry on as just the same. And so, but that view is the view which many people would contest, because of course this is saying that consciousness is an incidental feature of the universe. Now, other people, including myself, would say, no, consciousness is fundamental. And what does that mean? I mean, I mentioned before that although physics have been very triumphant in coming to describe all the structures of the universe, it doesn't make any reference to consciousness. It doesn't make any reference to mind, okay? And to me, this shows that something is missing. This is why we started off talking about the irony of the title, The Theory of Everything. The theory of everything does not refer to consciousness. So from my perspective, consciousness has to be fundamental. And I'm not going to go through all the reasons for that. I mean, the sort of reasons, very briefly, the anthropic argument, which we talked about, the hints from quantum theory itself that consciousness may play a role in the collapse of the wave function. Also the whole area of parapsychology, which again most physicists are skeptical of, but that hints that consciousness directly interacts with the physical world. So the question is, how do we reconcile this view, the view that comes from mainstream science and most cosmologists, if you like, that consciousness is just the ephemeral fluff generated by the brain, the culmination of complexity, which presumably didn't exist before planets and stars and galaxies formed. How do we reconcile that with the view that consciousness in some sense is fundamental? Now, I take the view that consciousness is fundamental. And to me, I'll tell you how I personally reconcile it and how many other people reconcile it, but this is not the mainstream view of physicists, obviously. I think of when you've got consciousness at the top of your pyramid of complexity, that is the consciousness associated with the individual brain. It's consciousness with a little c. But you can also have a picture which says that underlying everything, the whole universe is consciousness with a big C. Okay, and this is so this consciousness with a big C is, if you like, represents universal consciousness, and so the idea is that this universal consciousness underlies. So you've got this pyramid of complexity. The pyramid of complexity, in its traditional form, just has a little c at the top. All we have to say is, well, there's a big C at the bottom. The whole thing is in some sense within consciousness, but it's not within our individual consciousness, because obviously individual consciousness was only generated after 10 billion years or whatever. This has to be a different form of consciousness, which I suppose, if you want to use theological terms, you might want to associate with some universal mind with a capital M, or even God, but I prefer not to use theological terms because they have all sorts of other connotations. But to me, that's the important point, that underlying everything is consciousness with a big C, or if you like, mind with a big M, so that our minds with a little m are just a microcosm of mind with a big M. Our consciousness with a little c is just a reflection of consciousness with a big C. But this is a dramatic view, because this is saying that the brain is not actually generating consciousness. It's saying that the brain is a filter of consciousness, and that in some sense consciousness with a big C is being channeled through the brain to produce consciousness with a little c. And of course that is not the mainstream view. Most neuroscientists will think that's rubbish. Most physicists will think this is rubbish. But of course it's an old philosophical idea. You know, it goes back to people like William James and Henry Bergson and Huxley more recently. And actually, I think there is evidence. It's actually experimentally rather hard to distinguish between whether the brain is a producer or a filter of consciousness, because to do experiments is rather difficult. Because, for example, you know, there's no doubt that there's a correlation between what goes on in your brain and your experience. You know, so that if you eat an apple, something lights up in your brain, you know, corresponding to eating the apple. So there's no one's denying that. No one's denying what the neuroscientists find, that there is a correlation between what you experience and what is in your brain. But that doesn't tell you that consciousness itself is generated by the brain. It's merely telling you that when consciousness perceives the world through your brain, how it perceives the world is affected by what goes on in your brain. And that relates to the issue we talked about earlier, that how our perception of the world is affected by things that go on in the brain. So that's, I'm not sure if we've quite gone in the direction you wanted us to go, but to me, the crucial point about consciousness is that you've got to make this distinction between consciousness with a little c and consciousness with a big C. Most psychologists, most neuroscientists, most physicists don't believe in consciousness with a big C. And that's why this is a radical proposal. But nevertheless, to me, this is the only way to make sense of certain types of data.
Yeah, no, look, it's a thanks very much for making that series of links and taking that loop sort of back to where we began, because it feels very helpful when you step by step, coming from the point of view of actually engaging with these debates at the coalface, and then trying to explain them, rather than, you know, as I do, even though I did a physics undergraduate degree, inevitably I'm sort of trying to feel my way through darkness. But I particularly like what you touched on there at the end, because I wonder, and again, it's just suggestive, but I wonder whether it links to Dante's experience. You know, I wrote this book on the Divine Comedy, and in the Paradiso, right at the end.
Have it by my side.
Oh, very good. Thank you so much. Yeah, so right at the end, when Dante is in the Empyrean, which is the place increasingly where you might say his small c consciousness is less and less mediated from the big C consciousness.
Less and less mediated, yeah.
Yeah. So he you know, less and less filtered, to use the word you used before there. He uses a series of images which might suggest some kind of unfolding of his small c consciousness to recognize its unity with the big C consciousness. He talks about, you know, leaning into a river, drinking from it, the river's straight, and then now it's circular, and then the circular river itself kind of unfolds and becomes an amphitheater, and he's aware that he can be anywhere in this amphitheater just by the power of thought. And then that amphitheater becomes a rose, the famous white rose at the end of the Divine Comedy. And that takes things even further, because he realizes that he's everywhere all at once, as everyone else is all at once, much as, you know, the rose petals can be seen distinctively, but they also strangely merge in a white rose, in a very beautiful white rose. And then ultimately he knows himself to be spinning with the love that moves the sun and the other stars, which I think is an expression of a kind of unitive vision. It's very subtle, because he knows himself still, but knows himself to be part of that whole. It's not a kind of dissolution of himself, as sometimes people describe, I think. It's something genuinely new has been unfolded, but that was perhaps implicit all along. So I just wonder, I mean, sometimes physicists do draw on Dante. I know that in a different way, Carlo Corelli has been quite inspired by Dante in terms of his relational understanding of things. That's a whole different area, although it's kind of interesting because it does feel like it's trying to knit together experience as well as the purely objective approach that it seems that most physicists are inclined to go along. But just does those Dante images, you know, make some sense to you? Yeah.
Obviously, I am not as familiar as you are with some of these images. So, but I was particularly struck by what you just described. So I will react to that. It seems to me, I mean, I like the way you described Dante's experience in terms of his little c in some sense becoming part of the big C. I don't think that's probably the way Dante's work is normally described, but it seems to me that is, in a sense, this is the essence of all mystical experience, that you realize that actually your little c is ultimately an illusion, that you are, all the little c's are connected as part of the big C. And it seems to me that a mystical experience, though I'm not talking from experience, you know, I'm just talking from the literature, that it seems to me that mystical experience is a matter of your little c becoming aware of the big C. Except I would say it isn't just one step. It's not like you go from one little c to one big C, human to God, if you like. I feel there's a hierarchy of steps which you go through. You know, so if you like, increasingly big C's till you get to the biggest C of all, whatever that is.
Yeah, no, I agree with that. I think part of the genius of the Divine Comedy, and particularly the Paradiso, given that this is what it's describing, is the way that Dante does indeed break it down.
His journey shows it is a hierarchy. And I think that's so important because it shows that in some sense, you know, consciousness, there is a hierarchy of consciousness. You know, we humans assume very egotistically that the only form of consciousness in the universe is their form of consciousness, the sort of consciousness associated with brains. And it seems to me this is a very arrogant statement. I don't see why consciousness couldn't exist on many different scales. And I'll come back to this later, perhaps, but it seems to me that consciousness always assumes there's some form of specious present, which is the minimum time scale of consciousness, which for humans is something like a second or a tenth of a second or something. So that's our consciousness is defined by the fact that we experience things in bits of something like a tenth of a second, and we're not aware of any time smaller than that. But it seems to me that that's our human brain-based consciousness, but it seems to me that there could also be consciousness with very different forms of specious present. I mean, even within the physical world, you don't need to be talking about mystical worlds. Even in the physical world, I don't see why a computer couldn't have a specious presence of a nanosecond, and why there couldn't be some you know, galactic civilization with a specious presence of 1 million years or whatever. So it's very arrogant to assume ours is the only form of consciousness. And my own view is that there's actually likely to be a hierarchy of levels of consciousness in the universe corresponding to the hierarchy of of scales. You know, you go from humans, the planets, the stars, the galaxies, to the cosmos. I don't see why there shouldn't be a hierarchy of consciousness on all those different scales, which might be associated with a hierarchy of specious presence. And I mean, that's just, it doesn't depend on that assumption, but that in my particular model, that's the case. And so it seems to me that when you talk about even mystical, I mean, I'm talking about the physical universe, but even when you talk about mystical paths, they also seem to me to refer to a hierarchy of specious presence. And it seems to be in psychic and mystical experiences, you can experience that. I mean, just to take a very simple example, if someone has a near-death experience, they may see their whole life, 100 years or whatever, as being instantaneous. So they're viewing their life from the perspective of a consciousness whose specious present is 100 years, for example. Okay, so because within the specious present, there's no distinction between past and future. And well, Dante wasn't, I guess, talking about near-death experiences. Well, maybe he was, but at least I
mean, it is one way of describing, yeah, but not normally. It's not after a sort of trauma or a shock. Yeah.
But in any case, I think the message is that consciousness can be experienced on different levels. And not only that, the whole nature of identity is linked to that, because you and I are only separate because we're only separate at the level of our specious presence of a tenth of a second or something. Whereas we could be all part of a higher order identity where we're all the same with a longer specious present. And in that sense, the separation between you and I is an illusion. I mean, we're separated at this level, but not on this at this higher level of reality. So when Dante talks about being everywhere and being everything, that's precisely what this highest level is, because the point is your consciousness is your consciousness just describes the contents of your consciousness. Basically, is the sensations that come from your particular senses. So if you're perceiving through your brain, okay, you're localized where your brain is. Your little consciousness is localized, but once you become one with all these consciousnesses, you're perceiving through all the brains. Okay, so you're perceiving from everywhere. You are everywhere because essentially you are the universe. So I think that, I think it's a beautiful idea. And
do you think? Sorry, please.
No, that's fine.
Yeah, well, just one more thought then to relate that. I wonder as well about the significance of self-consciousness, that that we can be conscious of being consciousness and of conscious, and whether that perhaps brings in some capacity to navigate across these different scales of consciousness, whether that would be something that you might emerge from what you're describing. I mean, it's interesting. You talk about the kind of the physical world and then the mystical world, but sometimes they do come together. There's the apocryphal story of the Zen master who can catch a fly in between a pair of chopsticks. And if the fly's specious present is, I don't know, 100th of a second, which is why most of the time the fly easily escapes our whack. Perhaps the Zen master has developed the capacity more voluntarily to move across different qualities of time, different dimensions of time in the sense of scale, and so similarly, would be more alert to the unifying tendency as it moved up, as the consciousness of that person moved up the scale rather than down.
I think that's right, and I've heard. Who was this? Ed Kelly had this nice description. He says when you read some of the accounts of these, in the Pantanjali, the accounts of their experiences, it's almost as though they're changing a frequency. It's like they're tuning like a radio, and they're tuning to a different specious presence in my language. They're experiencing the world on a range of different timescales, and they can choose what specious present. I mean, not obviously this isn't what most of us do, but this is meant to be people who are mystically evolved. They in some sense can experience the world at these different levels of consciousness. And it may be very long, or it may be very small. So, you know, you'd even see references to states of consciousness where essentially the whole history of the universe exists in one go. You know, like just in the near-death experience, when you see your whole life, it was said that Buddha, for example, could see the whole history of the universe in one go. His specious present was the whole cosmic time scale. On the other hand, there seem to be mystical states where your specious present is essentially zero, you know, where all that exists is now. So it's almost as though you've got these limited states in which the specious present is zero or infinity or something like that. But I think there is actual evidence, if you like, if you take seriously the reports in the mystical literature, that one can experience different specious presents. And to me, that's telling us something, I think, very, very important about the nature of consciousness. I mean, you're asking about self-consciousness. And of course, you have to be defining what you mean by consciousness and self-consciousness is quite complicated. But to me, the real issue of self-consciousness is the question of self. To me, the question which I'm really obsessed with at the moment is, why am I me? Why am I Bernard and not Mark? Okay, and to me, this is a complete mystery. Let us imagine, for example, that you and me were born at the same time in the same maternity ward in our next door beds. Okay, so we're both born. Your brain lights up and my brain lights up. But the question is, why am I in my brain and why are you in your brain? Now, a materialist, 99% of neuroscientists would say, that is a meaningless question because it presupposes that there is a self distinct from the brain. You know, I can only say it's my brain because there's something outside the brain which becomes connected with the brain. And if you think consciousness and self-consciousness is generated by the brain, that is a meaningless question. Okay. However, it can't be a meaningless question because it's clear that I am me and I'm not you. And so to me, it's clear at the outset that the materialist perspective that consciousness, self-consciousness is created by the brain doesn't make sense. However, this is an argument I've made to countless philosophers and neuroscientists, and none of them accept it. I don't know how you react, but it to me seems such an obvious argument that to me it is very compelling that you have to go beyond the normal materialistic perspective. You've got to go beyond our normal idea of space and time to even address the question of what is the nature of self-consciousness. It's not, because what is clear is that within physics itself, there is no consciousness. Let me elaborate. Within relativity theory, there is no passage of time. There is no consciousness because, you know, in relativity theory, you've got the block universe, past and present coexist. We have this naive view that we're sort of going from past to present to future, like a bead on a wire on the world line of the brain, for example. But that's not true because in relativity theory, there is no now. So we know relativity theory can't refer to consciousness. Quantum theory, admittedly, may make some reference to consciousness, but the issue of time, the passage of time, is equally mysterious in quantum theory. So I would say that the nature of consciousness cannot be, it must go beyond both relativity theory and beyond quantum theory. But that's no problem anyway, because we know our final theory of physics has got to go beyond relativity and quantum theory. We know that relativity and quantum theory are very successful in their own domains, but they're incompatible. So we know there has to be a theory of physics which is going to amalgamate relativity and quantum theory. That is the theory of everything in the film title. And the question is this theory of everything going to refer to consciousness? Will the marriage of relativity and quantum theory involve consciousness? Well, I'm arguing that it will. But I'm also arguing you won't find consciousness at the relativity level of relativity theory or quantum theory. You'll only find it in that final theory. But then the question is, okay, if consciousness is in this final theory, how does it come in? And then we come back to the question, why am I me and not you? Because the question of now, which is why is there a special point in time, is very parallel to the question of why am I you and not me, which is the question of space. Okay, the two problems are linked. But what I would say is that the only way to address the question of self-consciousness is to go beyond the normal description of space and time. And in fact, I would argue that you have to have different levels of time. You have to have higher levels of time. Now, that is a feature of my own theory, which I haven't really talked about, but it relates to the idea of specious present. So all I would say is, I mean, I don't claim to be able to answer this question because that would be very arrogant. But I do think that the reason I'm me and not you is to do with the fact that there are higher levels of time, and that you and I are separate at one level of time, but at another level of time, you and I are the same.
Well, I think that this makes sense reflecting on fairly ordinary experience, actually, not just mystical. I mean, I work as a psychotherapist, and one of the things you become very aware of because of the structure of the psychotherapeutic hour is the experience of time and also the experience of connection in that period. And both change. And I think that it's only highlighted in the psychotherapeutic experience because of the way the thing's structured. You sort of, as it were, hold quite a lot of variables at bay and then pay attention to what's going on. But, you know, in a conversation, even in our conversation, there are moments where I feel I'm having to listen to you and take something from you, you know, as if you're separate. But then there are moments perhaps when it feels like it comes together more. And maybe, you know, when I bring in the Dante images, that's the sense in which we're becoming aware in our dialogue of something emerging between us. And so maybe that's, you know, nudging towards this sense of connection rather than separation, even in a relatively ordinary experience. And then similarly, you know, the same thing can happen with time in the psychotherapeutic hour as well, where it's actually a very good test of how, you might say, deep you're going with the person, how you're experiencing time passing. And if you're kind of watching the clock, you can fairly safely assume that you're not going very deep. But when suddenly the session's over and you hadn't even realized that time was passing, that's probably because you're touching something quite profound, something a bit more timeless in the person's psyche, and, you know, timeless therefore in reality as well. So I very much warm to what you're saying there, because I think it actually it relates to everyday experience, even if we just pay that little bit more attention to it.
I'm fascinated you're saying that, because I must say I've never visited a psychotherapist, but of course I've had conversations, and we're having a conversation now. And I think it's undoubtedly true in everyday life, you know, that there are already hints that we are connected with other people. I mean, you know, you can talk about mystical experiences which make it explicit that we're connected, if you like, with high levels of consciousness. But I think this is going on all the time at the mundane level. Now, of course, that's why I'm interested in phenomena like telepathy, for example, because telepathy is basically a manifestation of the fact that our minds are really non-local. They're not confined inside our heads, because our minds are connected in some sense. And I think that in certain relationships, obviously in intimate relationships with people you love, but also just maybe in your interaction in a psychotherapy session, you become aware of that, and you pick up information which you couldn't perhaps explain just by ordinary transmission of words. And I also think you're right that it's also to do with the nature of time, because, you know, the level at which you and I are connected is at a higher level of time, so that when you feel that connection, it's because in some sense you're accessing that higher level of time. So I find, because you see, what interests me is that we keep talking about, you know, all these transcendent mystical states, but really the problem is mind in general. You know, we want a model of mind. And there's normal mind, there's, like, if you like, paranormal mind, and there's mystical mind. All of them have got to be explained, and because philosophers and physicists can't explain normal mind, let alone paranormal mind, which of course that's to say psychic phenomena like telepathy and clairvoyance and premonition, which most scientists tend to be rather skeptical, obviously, and of course, let alone mystical mind, which is even more transcendent. So what you're sort of saying is that these issues arise in everyday life, every time you visit your psychotherapist, perhaps. Yeah. And I think that's absolutely correct. And I think ultimately that, because at the end of the day, most of my physics colleagues aren't going to have mystical experiences, and they might not even have psychic experiences. I regard psychic as sort of a little bit less elevated than mystical, but you know, there's a continuum of experiences going from normal to paranormal to transpersonal, if you like. But even my normal non-mystical physics friends, they can still notice in everyday life there are things happening which have got to be explained.
Yeah,
which pose a mystery.
Yeah, no, I mean, I like that, because it also actually, in my mind, goes back to something which you said at the beginning, which is that the importance of the beauty of the images that these tremendous telescopes like the James Webb throw up. And of course, certainly popular scientists, if they're writing or making TV programs about these images, that will be the most important thing, actually, as we punters look at the image, the sense of wonder, the sense of mystery. And I don't think you can really have an experience of something being beautiful unless it's connecting with you in some way. It ceases to be an object just out there, you know, way away, you know, looking at it before you were even around. And it starts to be an object that's connecting with your consciousness now, that shows up as beauty. You know, beauty in some ways is a measure of connection. It can disturb, of course, but the reason why it disturbs is because it connects too. So maybe this even links back to things which are, in fact, everyday in science, certainly science communication. You know, maybe even beauty as a measure of truth as well, which you know would be another element that you know, perhaps more scientists would affirm.
Well, I mean, this goes back to the issue of why physicists are so reluctant to sort of put mind into physics. You know, why they emphasize the mindlessness rather than the mindfulness. Because actually, if you think about it, the physics itself is really only producing a mind-like picture of the world, because our theory of reality now, you know, is really our picture of physics is a sequence of mental paradigms which actually bear very little relationship to our common sense experience of the world. I mean, the history of physics is demolishing all the common sense views of space and time. You know, objects are actually mainly empty space, and then, you know, like the atom is mainly empty space, and then the objects in the atoms are waves and not particles and things. So, and then we've got higher dimensions and things like this. So the whole history of physics is basically a history of mental paradigms. And not only that, you know, I think Jeans, who said the world was more like a great thought, you know, when you look at the universe, it's like a thought. And also you see the beauty. I mean, and it was Dirac who said beauty in equations is more important than the actual, even the data, because beauty is what's important. But of course, beauty, and the beauty you also see in those pictures from the James Webb Telescope, beauty is an aspect of mind. Okay? And then there's the whole business of mathematics. You know, physics relates to mathematics. Everything's described by mathematics. But actually, mathematics is also a creation of the mind. Okay, you've got mass, which produces the laws of physics, which produces the Big Bang, and the universe, which produces the mind, and you get a closed loop. And so in some sense, I'm a physicist, obviously, so I'm a bit biased, but to me, mathematics is almost like the language of God. It's really fundamental. But mathematics is fundamentally mind-like. So all of these things somehow, to me, hint that mind is important. So when I talk about this everything being in this consciousness with a big, you know, mind with a big M, that includes all these things like beauty and mathematics and meaning and emotion, and that all becomes part of this bigger description of the universe, in which the material world is just a small part. I mean, I haven't actually even talked about my own theory yet, I suppose, but I mean...
Well, I mean, if you've got some time, because Eve, only just to say that I think what's really important about you talking on these things is that you are actually working on a theory within physics that might embrace these things,
Okay.
not just speculating as I might. Yeah.
I'm happy to talk about these things. Now, the only thing, Mark, is you must guide me, because in theory, we were only going to talk for 1 hour, and we've gone past 1 hour, but we're in a different sort of specious present where time is traveling at a different rate. So how long can I go on for? I mean...
Yeah, well, look, please, you know, let's at least get into this next sort of paragraph, if not quite chapter.
Okay,
but I mean, it's really worth hearing if you've got the time.
I've got the time.
Yeah.
But and you can split this into two if you need.
Yeah.
For you.
No, I think you know, there's something really valuable about longer form conversations, because it enables us to muse and feel our way around, and so try and take on board a little bit more.
Yeah.
So please.
And can I just preface this by making one other remark, which has come to mind? You were talking, because it really relates to your very first question about when we make observations along the past light cone, you remember. I want to make this point. In the Newtonian view of the world, you just have 3 dimensions of space and 1 dimension of time, okay? And we know that there's communications. You know that the brain is one such object. So you're looking at the star, and there's a light ray that travels from the star to your brain and things. And because of that 3-dimensional Newtonian perspective, you make this distinction between what's in the brain and what's out there. There's the distinction between naive realism, if you like, and representative theory. But that was Newtonian picture with 3 dimensions of space and 1 dimension of time, where that time and space are absolute. But we all know that in 1905 Einstein came along with his special relativity, which said that reality is actually 4-dimensional. Okay, and space-time emerged. Time is the 4th dimension, and everything has to be described in terms of space-time, and objects are world lines rather than 3-dimensional objects. And of course, now we know that picture is correct. I mean, at least more correct than the Newtonian picture. And it has all these strange predictions, such as different observers measure different time in different ways and measure lengths in different ways, and things like that. But the point I want to make, which is very important when you think about the nature of perception, okay, because in a 4-dimensional description, your brain has got a world line. Okay, I'm going to have to try and describe this without a diagram. So it's like a line in space-time. That's your brain. And then when all the objects you observe, they're also lines. They've also got world lines in space-time. And then you can imagine that there's connections between those objects in your brain, which are it might be light rays, it might be sound waves, it might be all sorts of ways. But it's a way of transmitting information from the objects to your brain. But now let's take the star, okay? So we have a star, a distant star, and we've got your brain. And in relativistic terms, there is a light ray which is connecting the star to your brain, okay? Now, the point I'm making is this, that the perception is a 4-dimensional process in this picture. The star and your brain are simply 2 ends of a 4-dimensional chain. And this is really important when you address this question, you know, what is the distinction between the physical world and the phenomenal world? Because in the Newtonian picture, you're forced to say they're separate. One's in your head and one's out there. In the 4-dimensional picture, it doesn't make sense to say the star in your head is different from the star out there, because the perception is a 4-dimensional process. And so you have this view of a sort of extended mind in which your mind, what you experience in your phenomenal world, I'm talking about experiences of the physical world now, your phenomenal world is just that part of space-time to which you're connected, your brain is connected by this nexus of signaling lines. Okay, so it's easier to use a diagram, but I won't. You can imagine your world line of your brain, and at any moment you've got this sort of nexus of, I call it an outlook tree. It's all these space-time connections going into the past, which are connecting you to different regions of space-time. So the light cone, for example, is just part of that. When we're making observations through a telescope through James Webb, we're looking at the light cone, which is the outline, you know, the edge of this outlook tree. But there are other ways of experiencing the world. You can touch it and listen to sound waves and things like that. So, but the point is, your experience of the world is just this nexus of space, the part of space-time connected to your brain. Now, that's not controversial. I mean, that's just a description in relativistic terms of the process of perception. But it's very important because what it's saying is that you have to think of perception as a four-dimensional process. And so when you talk about the relationship between your phenomenal world and the physical world, you have to see it in four-dimensional terms. And that gives you a completely different philosophical perspective from thinking about it in Newtonian terms. Because in Newtonian terms, you're forced to say that the star in your head is different from the star out there. Now, that's Newton's picture. Now, the point is, though, that physics goes beyond that, because physicists around about the 1920s started saying, well, look, how can we be sure there aren't other dimensions beyond the dimensions of space and time? And in particular, Kaluza and Klein, two physicists, they said if we have a fifth dimension, this fifth dimension could mathematically have a geometrical interpretation of gravity and electromagnetism. Einstein had produced a geometrical picture of gravity which says space-time is curved, so that space-time sheet is curved. So that was a geometrical interpretation. Kaluza and Klein said, well, look, if we had a fifth dimension, but the fifth dimension is wrapped up very, very small. I mean, obviously we don't see the fifth dimension, but that's because its size is much less than the wavelength of light, so you can never see it. But the point is, this produces a beautiful mathematical unification of gravity and electromagnetism. That was in the 1920s, and it's quite a nice idea, but people more or less forgot about it because they got distracted by quantum theory and things like that. But now, in the 1980s, superstring theory came along. And, for example, that involved my colleague Michael Green at Queen Mary College. He was one of the fathers of superstring theory. And that said that, well, we need more extra dimensions, which are all compactified. We actually need 6 extra dimensions in the popular version of string theory, superstring theory. And so you've got 10 dimensions in total, okay? And again, you don't see any of these extra dimensions because they're wrapped up very small. But this, again, gave a beautiful description, not just of electromagnetism, but it's meant to be describing all the other interactions in physics, because by now, of course, by the mid-1980s, there were many other physical interactions besides electromagnetism. It was found that there were different versions, there were about 6 different versions of superstring theory, but then in the mid-1990s, it was realized that there was a bigger theory called M theory. And M theory, in some sense, married up all the versions of superstring theory, but this time it had 11 dimensions. Okay, so it had 7. You had the 4 external dimensions, 3 space and 1 time, and you've got these 7 extra dimensions. And that was a beautiful description. Now, a lot of physicists thought this is just mathematics rather than physics, all in the mind. You know. So it's controversial, and there's still not evidence for this from an empirical point of view. We haven't found these extra dimensions through the Large Hadron Collider, for example. So some people say it's all philosophy. I disagree. I mean, it may be wrong, but I'm sure it will turn out to be useful because it is a beautiful description from an intellectual point of view of amalgamating our knowledge of physics. But the key point I'm making is it involves these extra dimensions. So the history of physics has been really one of increasing dimensionality. 3 dimensions of Newton, 4 dimensions of Einstein, 5 dimensions of Kaluza-Klein, 10 dimensions of superstring, 11 dimensions of M theory. Now, there's one particular version of M theory which I like, which says that you take one of these dimensions, I said they're wrapped up very small, but now I extend one of them, and then I can think of this as being an extended 5-dimensional space, and I think of the physical world as a 4-dimensional brane, that's B-R-A-N-E, in a higher dimensional 5-dimensional bulk. So remember, this is a picture coming from physicists.
Yeah, yeah.
That's called the Randall syndrome. Doesn't mean all physicists believe it, but these are respectable, brilliant physicists, you know, who are famous in getting big salaries and professors and all that. So this is respectable physics. But the thing to bear in mind, this is a form of reality which bears no resemblance to our common sense reality, which is how we experience the world, which is the point I made before. It essentially is a mental model. It's a mental mathematical model. But to me, that doesn't mean it's bad. It just means that's the fundamental nature of reality is mental rather than physical. But now, let me just park that thought. But now let's come back to mental experience. The point I want to make now is that if you think of mental experience, I'm not going to try and define consciousness. I'm talking about the contents of consciousness. It seems clear that most mental experience involves some form of space. I mean, even the phenomenal space, you know, corresponding to the physical world is a space. Okay, that's what philosophers talk a lot about. But I mean, but we have other sorts of space. For example, I have my dreams. And when I have lucid dreams, I'm not sure if you have lucid dreams, but I often have lucid dreams, and I simply can't tell the difference between whether I'm awake or asleep. I mean, I can tell normally for various sort of cognitive clues, but what I do know is that dreams take place in a space, and it looks just like ordinary space. It clearly isn't physical space, but it looks like space. You could, going more exotically, because of course everybody has dreams, but if you have an out-of-body experience, it takes place in a space. Okay, now in fact it looks rather like the space of physical space, but there are reasons to think it's not exactly physical space because it's distorted in various ways. You know, you go out of your body and the chimney's the wrong color or something like that. But nevertheless, it seems to relate to physical space. But then you might go off into more exalted realms and where it's not like physical space, but it's always a space. Other phenomena, things like ghosts, apparitions. Most people, most scientists will say ghosts are just hallucinations generated by the brain. We've already seen how the brain can alter reality. But it's not as simple as that, because sometimes you have collective apparitions where more than one person will see the same apparition. And again, it's as though it's in a space. It's seen from different perspectives, even though it doesn't seem to be physical space.
Mm-hmm.
And then you have near-death experiences. Again, that might involve an out-of-body experience, but it also involves sometimes going through a tunnel, meeting the being of light, but it's still a space. And then even many mystical experiences, the extroverted mystical experiences, seem to involve a space. Now, space and time may be very different. I mean, there may be experiences of time and experience of space may be very different from normal physical space, but there's still a space. So the message I get from this is that mind needs a space. Okay. But it's not normal physical space. So in my approach, I say this space is a higher dimensional space. And indeed, this higher dimensional, I'm not saying how many dimensions there are, but I'm saying that if you have this is a higher dimensional reality. Okay, because what I'm saying is that all these phenomena are not just in the mind. I'm saying that outside, they are part of a broader reality. I'm saying that it's not just the physical world which is real. I'm saying in some sense, all these experiences are real in the sense that they're communal and that other people experience them as well. And so there's this higher dimensional space, and we as individual observers see different projections of this space as our experiences. But now I want to put these two pictures together, because here you've got the view of physics, where you've got the physical world as a brain, a slice of this higher dimensional, 5-dimensional bulk, And now I've got a picture where the physical world, phenomenal, you know, what I was calling phenomenal space, is just a slice of a higher dimensional reality structure.
Mm-hmm.
I mean, you might as well call it a universal mind because it is fundamentally mind-like. So what can be more natural to say these two spaces are the same? Because within physics, after all, if we go back to the Reynolds-Sundrum picture, we're on the brain. So what else exists in this bulk? Well, the only things I'm aware of is my mental world.
Mm-hmm.
So although I'm sure most physicists will think this is a crazy idea, to me it's entirely logical to identify the higher dimensional space of physics with the higher dimensional space required to accommodate not just ordinary mind, but also paranormal and transpersonal mind.
Yeah.
So that, in a nutshell, that is what my picture is. And then it's a little bit more complicated because then you've got to ask, well, what are these extra dimensions? And in my theory, which may of course be completely rubbish, but my theory says the extra dimensions actually correspond to higher levels of time, and they correspond to you remember the extra dimensions, even in conventional M theory, can be compactified. I mean, most of them compactified on a scale very close to the Planck scale, which is the smallest scale you can have, it 10 to the minus 33 centimeters. Remember, one of them is extended in this brane theory. But this is a variance in which you say you've got these scales are all compactified, but they're actually compactified on a hierarchy of different scales. So this is my particular model. And then the punchline is that I associate, it's the punchline which most physicists wouldn't believe, but the punchline is that this hierarchy of compactified dimensions correspond to the hierarchy of specious presence. So I'm associating extra dimensions with a hierarchy of consciousness. But anyway, regardless of whether this theory is right or not, it's an example of how, in principle, you could link physics with mind, how you could extend physics in a way which will accommodate mental experience. Because I was saying to you earlier that somehow we want to get consciousness and mental experience into physics. I was saying to you, if it's only going to happen at the final theory, where quantum theory and relativity theory merge. I'm now being more specific. I'm now saying a feature of that final theory is going to be extra dimensions, and furthermore, those extra dimensions are going to have something to say, have some connection with the specious present and the hierarchy of consciousness. But the point is, even if the theory is crazy, it's an example of how you can marry up physics with matter and mind in this extended theory. And I have to say, most of my physics colleagues will not believe any of this. They'll probably burn me at the stake, but I've retired now, so I can't lose my job. And I have to say, even my mystical friends aren't very keen on it because, by and large, mystical people try and keep away from physics. You know, they think it's reductionist. They think that if you're reducing something to physics, it's reductionism. So even the people on the mystical side aren't too keen on this, but it's not physics in the normal sense of the word. You know, it's a sort of, and it's not reductionist. In fact, I mean, what do you mean by reduction? You have to define what you mean by reductionism, but it's a higher dimensional picture. So it's you've got top down rather than just bottom up interactions, because the top down interactions come from the higher dimensions. So in a nutshell, that's what my theory is, and it's. I don't know how many people. Sometimes I think it's crazy, you know, but nevertheless, sometimes this is what I've been working on for 50 years, really. And I have to say, I had the glimpse of this theory when I was about 15 years old. I mean, I read some books, and somehow I suddenly thought, my role in life has to be to expand physics to accommodate mental and spiritual phenomena. And I had this flash that it has to be higher dimensions. And this was well before M theory came along. This was way back in the 70s, in the 60s. And then, but then I wasn't a physicist, and I just decided, well, if I want to extend physics, I better actually study physics. So I ended up doing a PhD in physics with Stephen Hawking and all that. And now I'm retired, I can go back to these ideas. See, my PhD supervisor, Stephen, wouldn't have believed any of this. He would have. I don't know. He might have changed his mind now. I don't know, because years ago. But I mean, nevertheless, this is my own. This is I feel this is what I'm passionate about, and I don't think many people believe it, but I can't help it. That's what I think. I think there has to be a paradigm. What I do believe, there has to be a paradigm which is going to extend science beyond the material domain.
Yeah.
I believe that passionately. Whether my particular paradigm is correct or not, I don't know. I mean, I like to think it is, but I could be deluding myself. But I bet you there is a paradigm, and I think this is the best way to go personally.
Yeah, well, look, thank you for sharing it. And I mean, maybe this is coming towards a final thought from me, at least, is that a word of encouragement, if any is needed, but from Barfield again, because Barfield actually through the history of words, so it has a kind of empirical base for him. He felt that human consciousness goes through phases of feeling more than, you might say, the unitive sense of participating with things, to feeling periods of alienation. But the alienation itself serves a deepening and renewed sense of participation that's to come. He called it final participation or reciprocal participation sometimes. And he tracked this with words. And what is doubly interesting for me, and so this is how he understood science. He understood science as this, in a way, a kind of exercise in part separating from what is being studied, but in order that a renewed sense of connection might emerge in time. So, you know, that the reductionism or the alienation is not the end of the story at all. And even more interestingly, perhaps, if this does relate to what you were saying, was that he found this through words, and he looked at how words have changed meaning over the period of written history, so maybe 3,000 years or more. So a fairly decent chunk of time. And he noticed how words, two things that might be relevant to what you're saying. One is that they originally move across different qualities of space. So take a word like pneuma in Greek or ruach in Hebrew, and it's the same, I think, in other languages as well. It's a really key word in lots of ancient texts because it means spirit, but it also means breath, and it also means wind. And it's very fascinating in relation to what you're saying, because when he looked back at, he thought all words actually, and it wasn't just him, other particularly researchers into words in the 19th century, it's a little less fashionable now, but they look back at the history of words and realize that all words have both a spatial meaning and an experiential meaning. You might say a physical meaning and a phenomenological meaning, and that what's happened in the 3,000 years of written history is that those meanings have often got separated out. But Barfield felt that that's a clue to the future of how the separation might lead to a renewed sense of connection. So I just wonder whether there's something related again to what Barfield is saying and to what you're working on in that.
I think there is, and in fact, I think I should one day I should interview you, Mark, so you can talk about this at great length, because obviously I've been doing most of the talking in this conversation, and I find that fascinating because, I mean, it comes down to the role of meaning too. I mean, physicists don't normally talk about meaning, but I do think when you talk about mind, meaning comes in, and I do think words do, and obviously that brings in the role of words as well. But and so. I mean, that's just another theme which would go off on a tangent, so I won't explore that. But I think the key thing is this business of connection, which you were talking about, and you know, I'm not an expert on Owen Barfield's philosophy, but I know he was an anthropophysicist.
Anthroposophist. So basically, he had his sort of realizations through his philology, through the study of words, and then realized that Rudolf Steiner, the founder of anthroposophy, had been saying similar things, and a whole lot more besides, it should be said, but nonetheless similar in relation to what we're talking about.
As I understand it, the purpose of anthroposophy, I can never say the word, the A word, is that you know, you are actually appreciating the validity of spiritual experience and relating it to material world. So in some sense, it seems to me that it's the remit is rather close to the remit which I'm talking about. I want to extend science to accommodate these experiences, and in some sense, if I understand correctly, that's also the goal of anthroposophy.
Yeah, no, he talked about a spiritual science, and
Yeah.
I mean, sometimes it goes into areas which I just don't even know what to make sense of. But a lot of it, you know, you can make a lot of intuitive sense of. And a good point of contact, I think, is through Barfield's study of words. You know, if I'm stood upright, and when I want to make a clear point that I think is true, I stand more upright quite naturally. But of course, upright is both a physical description, but also a phenomenological description. It sounds right to you as well. And so again, maybe in quite a lot of everyday experience, these things are naturally associated, and you know, the genius of what you're doing is trying to turn that into something that the physicists could appreciate as well.
But also, I do think words, they provide a clue, because in some sense, I think words at a subliminal level, they convey messages that go beyond the meaning itself. I mean, for example, I'm always interested in the contrast between experiment and experience. Okay, one always says that experiment is science do experiments, scientists do experiments, and then we have experience, and experience will never be part of science. But what I'm saying is that science has to be expanded to accommodate experience. You know, when we talk about mind and first personhood, we're talking about experience. And yet I'm fascinated that in French, it's the same word, expérience. Okay, and experiment. So in some sense, I'm not saying the French are particularly mystical or anything, but it's fascinating to me that in the French, they already have that link between the two words. And another example is the word gravitation in French is attraction. And attraction has connotations of love and things like that. So, and you do see some people saying, oh, well, gravity is like love, you know, but of course a physicist would never talk about love. But nevertheless, the word is linking them. And so, I mean, I'm not an expert on semantics, but there's so many examples where the word seems to be giving a clue of a deeper connection between things which seem to be from different worlds, but are actually the same world. And I mean, I'm sure, well, people must have written volumes on this topic, but I just find it, I can well understand Barfield's fascination with words.
Yeah, well, look, I mean, people do write about it, but it's very unfashionable, a bit like what you're saying about the brain and consciousness, you know, as filter rather than excreting it. It comes up in the accounts people give of the evolution of language, the emergence of language, and the standard story is a bit like the brain excreting consciousness, that we, you know, started off with grunts and squawks that gradually refined into language because of a essentially instrumental need. And whereas Barfield and others, and there are some scientists who opt for this route as well, and would say no, that language was in some way given to us through our increasingly self-aware appreciation of, say, these connections. And, you know, maybe it started with music first of all, that can make these links, and then music kind of refines, and no doubt because of a certain kind of instrumental need too, this refining and the emergence of language occurred. But the reason why words seem to make these bridges, or what C.S. Lewis, actually, Barfield's friend, called transpositions, moving from one dimension to another, is because that's where language comes from, and that place is itself some sort of reflection of reality again.
Yeah, because if you think that mind is fundamental, you know, words come from mind. So in some sense, you might expect, I mean, I guess words come from, I don't know whether language comes from the level of mind with a big M or mind with a little m, but I mean, it's fascinating to me that you might expect, especially if we're all connected in some sense, that you could expect that the words, the language is giving you a clue which goes beyond even what the person who coined the word was thinking about.
Yeah, no, I think that, I mean, you know, and again, many mystical traditions will talk about the logos, the words, the aboriginal utterance, those kind of things, for sure.
And it's not just words, because, you know, we talked about mathematics, and to me, mathematics is a language. Some people even say maths is the language of God, which I think is a bit pretentious. I think Rumi said that the true language of God is silence, but no, maths is a language, and as you said, music is a language, and the same thing applies to that. It's all, the creation of mind. And it was Chomsky, for example, the great linguist, he was one of the first people to say, physics must expand to accommodate mind. So it's interesting. It wasn't the physicists saying that, but it was the famous linguists making that remark.
Well, look, you've taken us on a journey across space and time, you know, back to 100,000 years since the Big Bang and into multiple dimensions, the possibilities there. So that maybe this is a point to conclude and for now at least, and you know, muse on what you've said, and then no doubt I'll be knocking on your door virtually or actually at some point in the future to ask my next naive question. But you know, thanks so much for picking it up and arranging and being prepared to go with it and explaining things. It's really so fascinating.
It's been very enjoyable. We've spoken for nearly 2 hours, but it only seems like 1 hour. And one time, next time I would like to hear you. I'm sure you've already actually talked about these things yourself, but I would like to hear you say more things about Barfield and of course Dante and things like that. But
well, look, I know that us followers of Barfield would be delighted about that, because you know, we feel that he's onto something, and so picking up that legacy and trying to help it illuminate where we're at now, it would be really great.
To be honest, I mean, I didn't know much about Barfield, but I know he was a great friend of C.S. Lewis, and of course also Tolkien, and I wasn't aware of his connection with Steiner and things like that. So it's, to me, that's fascinating. That to me has opened another door as well. So thank you for that.
Yeah, well, you know, his link with Tolkien is quite as vivid, and one of the reasons why Tolkien has these different characters in the Lord of the Rings, the elves and the dwarves and the hobbits and the humans and so on, is because they're beings that experience time in very different ways. The elves much more eternally and so on. So it's a way of writing imaginatively about insights that certainly Barfield helped seed in the minds of Tolkien and Lewis.